All right, hello everyone. Lab 10. This video, I'll go through steps 1 and 2, and then I have a second video for step 3 of Lab 10. All right, so we're in the second week of large data inserts. Okay, so in this week, in this lab, we're going to load data into the rental table, the rental item table, and the transaction table from the transaction upload table, okay, with 3 inserts. All right, so in Lab 9, where we left off in Lab 9, we created the transaction table, and there's no data in the transaction table. It's an empty table right now. And we created the transaction upload table. So we had a video store in our chain that closed, and we are now taking the data from that store and putting that data into our database, the historical records about the rentals for customers that went to that store, and we're loading that into our database now. Okay. All right. So the transaction table is very similar to the rental table. Okay, so I'll talk about that for just a minute. So the rental table, somebody comes into the store, they do a rental. All's well and good, but what if a DVD is scratched, does not play, does not work? They come back to the store, they need a refund. Okay, so we have a transaction table. So when there's a rental, we record a transaction. We call it a debit transaction. They pay us money, and so we're making money when someone does a rental, and so we insert data into our rental table, our rental item table when they come in to do a rental, and we insert a row into our transaction table that maps to the rental, and has a foreign key of the rental ID in the transaction table. And we hope that there's just a one-to-one, one rental, one transaction. But if something goes wrong and the customer needs a refund, they come back, then we make a second transaction for that rental, that same rental ID, that then credits the customer. And so for that one rental, we have 2 transactions, a debit transaction where they paid us money, and then a credit transaction where we refunded them money, okay? So the transaction table and rental table closely related. All right. Okay. Let's jump into the instructions for Lab 10. Let me share my screen here. All right. Okay, so we begin Lab 10 by running Lab 9, which runs Lab 8, which runs Lab 7, which runs Lab 6, which runs Lab 5. Okay, so our labs continue to incrementally build and depend on each other on the previous lab. All right. Um, the lab instructions start off here with this mapping table, a mapping of the transaction table to the transaction upload table. Okay, so I'll cover this more in my video with step 3 because it applies specifically to step 3, the insert to the transaction table. But know what this mapping table does, and you can construct one for steps 1 and steps 2, which can help you get your arms around what we're doing in taking data from the transaction upload and inserting it into these tables. So you see here every column for the transaction table is listed here. Transaction table, every column, and then where does that data come from? And you see some of the, the transaction ID comes from the sequence, right, as we normally do. Some data comes from the transaction upload table. Some data comes from the common lookup table because it's a foreign key lookup, a foreign key ID that we want from the common lookup table put in there. Here we need to get the rental ID, right? So that comes from the rental table. And anyway, and you see how the data is, where the data comes from, and then source column and how it's derived. Just note that here for the transaction amount, you see here when you get to step 3, it will be the sum of the transaction amount from the transaction upload table. And I'll talk about that more in step 3, but we'll talk about it here also because we want to understand what is the data that is in this transaction upload table. What did we get from that other store? Let's go to that. Let's go to that right now. Okay, so I'm going to go to a created a paint screen here, which basically has a describe, and here's the transaction upload table. I don't have transaction on here. That's step 3. We're going to focus on steps 1 and 2. Okay. So the transaction upload table, it has an account number, and that is a membership account number. Okay. And the membership numbers from that store are valid as membership numbers for our store. Okay. And then we have first name, middle name, last name, checkout date, return date, the rental item type, and the transaction type. Is it a debit or a credit transaction? Okay, and I just talked about that, right? The transaction amount and the transaction date. Now, the transaction date should match the checkout date, right? Which will be also the rental checkout, which is the same as a rental checkout date, right? And they do. Transaction date matches checkout date. The item ID. All right, so the item ID in our rental item table, the item ID is a foreign key, and it looks like I'm missing that right here. Let me add that right here in the rental item. We have, in the rental item table, we have to have an item ID. And that is a foreign key right to the item. I'm going to move that just to make that look a little better there. Oops. Better not do that right now. Come back and do that. Okay. So this is our data in the transaction upload table. Oh, I left off on item ID. So the same item IDs, the same items existed in that store that exist in our store. Okay, so our item table has the same items, and then the payment method type, which is the credit card, which credit card was used, and payment account number. Now this payment account number is really related to this transaction type, a debit or a credit. It's really a ledger account. In step 3, we're going to use that as if it was a credit card number. It's really not, but the transaction table is empty and we're not getting any matches in the transaction table. So we're going to use that like a credit card number to join on. It will not give us any results back, and that's what we want because the transaction table is empty, so we're not going to get any results anyway. Okay, so that's our transaction upload table. To load this data into the rental and rental item tables, what do we need to do? Okay, so we'll extract the data from the transaction upload table, and first we'll insert it into the rental table. Okay, so to create a rental, we'll have to create a row in the rental table, and to do that, we need to tie that rental to a customer, right? A customer ID, which is a contact. Now, in the transaction upload table, we don't have a contact ID. So how do we populate this foreign key here, customer ID, that has to point to some contact? Who did this rental? Well, we have first name, middle name, last name in the transaction upload table, and we have first name, middle name, last name in the contact table. So that will be useful to us. We can match on that data so that we can find the contact ID, so that we can put the contact ID into the customer ID of the rental, right? And then checkout date is there, return date is there. So pretty straightforward pulling the data from the transaction upload table, but we have to get that contact ID, and we also have here in the transaction upload table that account number, which is the membership number. Okay, so we have the member table here, and here's the account number and the membership number from our member table. So that's in play here. So as far as finding the right contact, we'll check. We've got first name, middle name, last name, but we also have this contact belongs to a membership. There's a member ID foreign key here, and the transaction upload table has an account number, so we can match on that account number to make sure that we are getting the right contact who belongs to the right membership to tie this new rental record to, which is a historical rental record that we are creating coming out of the transaction upload table. Okay. Let's go to now to the transaction upload table and look at it a little bit more. Okay, so I'm in SQL Plus here. I'm actually in gedit, and in the window, the terminal window in gedit, I'm in SQL Plus, and I've executed lab 9. Okay, so I executed lab 9, and this is the end of the results of lab 9, and that's our starting point for lab 10, right? So I'm going to do select from the transaction upload, and there are 11,520 of these rows in the transaction upload table. And I expect that Harry Potter has some rentals in there. So I'm just going to, I'm just exploring, right? So select from transaction upload where first name equals Harry. And let's see what that gives us. Hang on and let me see what's going on with this error message. Okay. Okay. I'm back. That was a silly error, and you probably saw what it was, but I didn't want to waste your time while I looked at that to figure that out. So I put in here select from the transaction upload. That definitely won't work. So when I select from transaction upload, that will work. Let's do where first name equals Harry. Okay, and now you see I get 768 rows. I'm going to put an order by on that. Let's order by the checkout date. And here we have all of the rows from the transaction upload table for Harry Potter. And the last one is 8th of January, 2010. And we can see that Harry, let's see, so that the checkout date is the 5th of January, the return date is the 8th of January, so it's a 3-day rental. It's a debit transaction. This is where he makes the rental and pays us, right? We have the amount you see here is $3.18. So For a 3-day rental, what is a 3-day rental on an older lease? It's $1 a day. It should be $3, right? So what the other store has done in the transaction in calculating the amount, they've added a tax, 6% tax. And so the amount that they show us here is $3.18 because there's a 6% tax in there. We'll have to think about that when we get into putting in an amount, because we want to put in an amount for a 3-day rental that is $3, not $3.18. Okay, and so the transaction date is the 5th of January, which is the same as the checkout date. This is the item ID, 1020, whatever DVD or Blu-ray, whatever that is, paid with a Discover card. And then here is this payment account number, which really is a ledger account number, not a credit card number. So here we see this record for Harry Potter. So we see above here, we look at the one right above that, and we see that it is exactly the same. So for this rental, well, what does that mean to us? It clues us in that Harry rented 2 items on that day, and that each row in the transaction upload table represents a rental item. It's at the rental item level, okay? And so Harry came in, did 1 rental on January 5th and rented 2 items. Now, he happened to rent the same item twice. Okay, so in real life, probably wouldn't do that every time he comes in to make a rental, but maybe he's getting the same item so that Ginny can take it and watch it in her room, or right? So it's the same item, but he has 1 rental here with 2 items. Okay, so we see here the rental on the 3rd of January. There's just 1 line here for the 3rd of January, a 3-day rental, and then we go to the 2nd of January, 1 line, and so 1 item. So, but on this one, there are 2 lines, 2 rows in the transaction upload table. Okay, so that's important. Harry has 768 rows in here, so does he have 768 rentals? No, he has 768 rental items, right? There's 1 row for each item that he rented, okay? That is really important to us. Because when we're inserting into the rental table, we don't want to get every rental item. We just want to get the information about the rental, right? So the checkout date, the return date, and the item numbers we don't care about when we're inserting into the rental table. So we've got redundant data here for the rental, because it's repeated, right? All the rental information is repeated, plus, and then you have the rental item. The rental information is repeated again, and then we have the other rental item. So when we're inserting into the rental table, we just want to get the rental data once, and how do we do that? So we do that with the keyword distinct All right, and distinct says throw away duplicates. Okay, so let's practice that here and see if that works. So again, Harry has 768 rows in the transaction upload table. We'll now select distinct. Checkout date from transaction upload, where first name equals Harry. Let's see what that gives us. That gives us 300 rows. 300 rows, right? Instead of 768 rows. Okay, so Harry has 300 rentals in here, and 768 whatever total rental items. Okay, so let's look at that again. So if we take out the distinct, we will get the 768 because checkout date is repeated. Let's just do it. Okay, select checkout date from transaction upload, where first name equals Harry. All right, there's our 768 rows. Let's order by checkout date. Okay, and so we see the checkout date repeat here now, just like we expected, right, for those 2 rows in the transaction upload table. But if we go to our distinct, and let's do the order by here too, order by checkout date, then we get the 300 rows, and the 5th of January only appears once, okay, because wherever it was, there were duplicates, those got eliminated. That's what we want for getting the data from the transaction upload table to the rental table, right, to get the rentals. Okay, so let's go back to our instructions and start here. So steps 1, 2, and 3, you're going to do the same kind of thing in each step. So the first thing you'll do is you'll construct a select query. And once that select query, right, you'll run that, it prints to your screen, and you know that you're getting the right data. Okay, so we do the select statement. Then we are going to wrap that select statement inside an insert statement. Okay, so we will insert into rental, and then we'll have this select statement which collects up all the right data to insert into the rental table. Okay, all right. So the first thing he wants you to do is to just explore in a little bit. You can discover the contact ID. So here you see the keyword distinct, and looking at contacts, and how do you find the contact? Well, we have we have first name in the contact table, and in the transaction upload table we have middle name in both, and we have last name in both. Right, and so you can run this query and take a look and see what it does. Now notice that the NVL function is here because middle names are often null in our transaction upload, in our contact table, right? Lily has a middle name Luna. Everybody else is null on their middle name. Oracle doesn't know how to do a comparison of null to null because null means it's undefined. There's no value defined. And so we use the NVL function here. And when it's null, substitute an X on both sides, and then Oracle can handle that. X compares to X, and it matches. It's really null on both sides. But by substituting the X, then Oracle can handle it and make the comparison. Okay, so make sure you understand that, what that line of code does there. Okay, you run that line of code, and you see that we get the contact IDs are 1 through 15. So there are 15 customers who did rentals in the old store, the transaction upload table. Let's go to and look at our contact table, okay? Select contact ID from contact. And we have 15 contacts. Exactly. We have exactly the same people who rented in the old store that shut down that rent in our store. So the contacts were good on the contacts. All of our contacts rented from the old store. We can see by this result here, and so we know that that we line up there with contacts. Okay, now let's get into constructing this select statement that's going to get this data so that we insert it into the rental table. Okay. The first select statement uses a query that performs the following joins. There aren't any subqueries in the statement, and the distinct operator is required to make it rerunnable. So no, not rerunnable. It's distinct isn't to make it rerunnable. Distinct is to throw out the duplicates so that we only have unique rentals. Okay, that's what distinct does. All right, so if we just follow the instructions here, you can construct the joins. Now, why do we start with the joins? Because that's where Oracle will start, okay? And so in collecting up the data, the first thing Oracle does, Oracle goes to the from clause and looks at the tables. What tables do you want me to get data from when you're doing a select, right? And so when we're thinking about we're going to collect up this data, we need to first think about the tables, where this data, the tables that the data is in, and then we'll list the columns. We'll in the top of our select, but we're going to construct the select by starting with the tables and joining the tables together. Okay, so join the member table to the contact table on an inner join. We've done that, I think, before, and we'll look at how to do that. Okay, then join the foregoing result set, and the foregoing result set is the result set of the prior join to the transaction upload table on an inner join. I want to talk about this for a minute here. The foregoing result set. This is how Oracle works. We will say from, in our from clause, and our first table that we mentioned here is member. And Oracle will say, okay, I go to the member table, and I've got all the rows, the memberships here, all the rows of the member table. And then we join that to the contact table. And what do we join on? Well, we join on foreign keys to primary keys, right? That's what foreign keys are for, so that we can link. And so we join foreign key to primary key. So what do we have in the contact table? We have the member ID, so we will join on the member ID, where the member ID in the contact table equals the member ID in the member table. We will join on, those two being equal. And Oracle will then go get the contact table and do this join. When Oracle is done, what do we have? So what Oracle does is Oracle constructs an intermediate table in memory after each incremental step, after each join here. So the join does two things. The join will add columns. So now we have all the columns of the member table, all the columns of the contact table, and we have those rows where the contact and member are equal. Okay, so if there are any memberships that don't have any contacts in them, then we won't see those memberships, but otherwise we have all the contacts and we have all the memberships, that belong to those contacts in a result table, in an intermediate result table in memory. Okay, so Oracle's holding on to that. Okay, and then what does Oracle do next? Oracle then goes to the next join. Okay, so then what are we going to join? Now we're going to join the transaction upload table. So we're going to do inner join on the transaction upload table. And after we do that, and how do we do that? Because there's no foreign key in the transaction upload table, but we talked about what we can match on. Okay, so I'll show you the pseudocode. I'm going to show you the pseudocode for this and let you write the actual code. Okay, so we'll take a look at that. And then the next sub-bullet here, join the foregoing result set to the rental table on a left join. Okay, so now Oracle does the join to the transaction upload table, and it goes out and gets all the columns. We now have all the columns of the transaction upload table in this result set. We have member, contact, and transaction upload, all the columns. And then we have those rows that have a match, and all of our contacts had rentals in that transaction upload table. So we've got every row in the transaction upload table now in here, in this result set. And now we do this left join to the rental table. Okay, what does a left join do? You can go back to Lab 5 and you remember that cute little animated table construction joins, those joins in Lab 5. Go back and look at those if you want to look and see what a left join does. I'll describe it in words here. Okay, so the left join takes everything on the left and then joins the one on the right, which is going to be the rental table. The rental table is the one that on the right side of the statement, right? And those rows from the rental table that match the rows on the left will get joined into the result set. But wait a minute. So we have member, contact, transaction upload, and we've got all the rows from transaction upload table all in this result set, and now we do this left join on the rental table. But the rental table, let's go and look at our rental table. That's everything. Let's do select checkout date from rental, order by checkout date. And we see that all the rentals we have are in February of 2018, okay? And in our transaction upload table, those are all, we ordered by checkout date. Well, we did Harry Potter. We could do all of them. Select checkout date from transaction upload, order by checkout date. And if I put a distinct in there, we'll get fewer rows. Instead of 11,520, we get 344 rows, so we have 344 rentals. And the last date, well, it is Harry's. Harry had the last checkout in there, apparently, 5 January of 2010. Okay, so hang with me here. We're going back to the instructions. We're now doing this left join to the rental table. And so all of our current rentals are in 2018. All of the transaction upload rentals are before 2010. So we're not going to get any matches. We're not going to get any matches. But that's okay. In fact, that's what we want. We don't expect to get any matches, but what this left join does, it's a technique to get the columns from the rental table. And that's what we need to come back in our select. We need the columns from the rental table, and specifically the rental ID column. That's really the column we want. Now when we do this left join, it takes everything from the left side, all the results from our first join of the first 3 tables, adds the columns for the rental table. But what's going to be in that column? Well, it's going to be null, but we have the column. And with a null column, we know what to do with a null column when we want to create a rental ID, right? We can use nextval, right? We're going to use nextval to create the rental ID anyway. So we'll use our NVL function where the rental ID is null, and it will be null, and the results here. Then we'll do rental s1.nextval, and that will generate the rental ID, and then we can insert that into our rental table. Okay. Hang with me. We're going to go look at the code. Okay, the pseudocode. The query to support the select statement to the rental table should return 4,681 rows, which is the same number that should go into the transaction table. Okay, and we don't need to worry about this key for the transaction table yet. We will get to that when we in step 3. Okay. The query in the select statement doesn't need to return the who audit columns. What are the who audit columns? Created by, creation date, last updated by, last updated date, and that's what Brother McLaughlin refers to as the who audit columns. Okay, that's his term, and so we will include those in our statement, but we're going to hard code those, okay, like we normally do. So you can disregard this part right here. Okay, so what should you get when you do this query, when you do this select? Here's your result table. Okay, here's your result table, and you see that the rental ID column is null because there were no matches to the rental table by joining the tables. But we got this column, and and then here are the other columns that we get: the customer ID, the checkout date, the return date, and then we're going to put in the who audit columns here. Okay. All right. So we left off up here in the instructions, but now we're going to. So I'm going to hold here where it says diagnostics, and let's go look at my pseudocode. Okay. How do we construct this query? Okay. So here it is, and so down here in the corner is some things for step 2. So we're looking at step 1 here. The goal is to insert into the rental table. Now we start with the from clause. Okay, so we're going to start over here on the right with the from clause. And then we'll work back over here to the stuff on the left. So we have member, and then we interjoin with the contact table. And how do we do that? We do that on the member ID, right? We'll use aliases here. You'll use alias. So M for member table, m.member ID equals c.member ID, right? You put an alias on the contact table, right? So member M, interjoin contact C on m.member ID equals c.member ID. And then Oracle creates then an intermediate table there. Then we interjoin to the transaction upload table. Okay, interjoin on the transaction to the transaction, interjoin transaction upload on, and then we'll do first name, middle name, last name. So C dot first name equals TU dot first name, right? And then the middle name, and we'll need to use that NVL function. And then last name, C dot last name equals TU dot last name. And then the account number, M dot account number equals TU dot account number, right? And so we are assuming that in a given membership, that any given person whose first name, middle name, last name is unique within that membership. Okay, so we're saying first name, middle name, last name, and that account number uniquely identifies the contact, because we don't have, right? We don't have the contact ID, but now we will have the contact ID when we join on those columns. Then the result, the contact ID in the result, is the contact ID we want to insert into our rental table. Okay, think about that, replay it if you need to, go back to the lab instructions and look at where Brother McLaughlin does that first query, right, where he does this matching on first, middle, and last name and the account number. Okay, then we do left join rental, and then what do we join on for the rental table? Well, we know that the checkout date, there's not going to be any matches on checkout dates, and that's what we want. But we join on foreign keys to primary keys. So in the rental table, we have The customer ID, which maps to the contact ID, the foreign key to the contact ID in the contact table. So rental c.contact ID equals r.customer ID, and tu.checkout equals r.checkout, and tu.checkin date equals r.checkin date. And there will be no matches here, but that's okay. That's what we expect. We just need to get that rental ID column as a null column into our result set. Okay? So that's our from clause with all the joins. Okay? So if you work through that, you'll have, and I would say work through it incrementally. Do the first join and run it and see what you get, and then do the second join with transaction upload table and run it and see what you get. Does that work? Then do the left join on the rental table and run it, get the result, see what you get. Okay. So here's the from. Now, what are we selecting? Well, we're selecting all those things that go into the rental table. So we're going to, in our select clause, we're going to select the rental ID. It's just the columns that go in the contact ID. What is the contact ID? We're going to get that from the contact table, c.contact ID. And then the checkout date from transaction upload, tu.checkout date, tu.return date. And then we just hard code these. 3, you could put 1 or 2, right? 3 as created by, trunk sysdate as created date, 3 as last updated date, trunk sysdate as last updated date, and there's our select. Now you see that we have alias names over here for these columns. So r.rental ID as rental ID, c.contact ID as contact ID. Okay, so there's our select. Now, what did we say? We want to eliminate. So there would be duplicate rows. Oracle in the results set will find duplicate rows here, right? Checkout date and return date and all, because of multiple items within that rental. So we have our keyword distinct that eliminates the duplicates and gives us just one row per checkout date, return date. All right, so we have our distinct here. Select distinct and our columns. Okay, now we have this outer select, and then we have the insert. So here's why we need to nest this select down here in the from clause with this outer select, because when we're using the distinct here, we can't put the NVL, use the NVL function and the distinct in the same select here. Okay, so that's why we have to nest this select. You can try that and see what happens, and Oracle gives you an error saying, no, you can't have select distinct and then NVL right after it. So we have this other layer of select out here. Okay. Okay, back down here we have this select statement, select distinct. Here are our columns, from, and here's our joins and our from clause over here on the right, and then here at the bottom is an alias. Okay, RX I called it. So what does that do? Again, Oracle, when Oracle gets done doing this select statement, it has in memory an intermediate table, and we can give that table an alias. And that's what this does. This RX is the alias for this intermediate table that Oracle creates. Okay, so the first thing you're going to do is just work on this select statement and get the select statement running. Then you will, when it's getting the data and everything's right with that, then you'll do this outer shell. Okay, you'll do this outer select with the insert. So get this running first. Okay, Now when we put on this outer select, now what are we selecting? We're selecting the same things, right? We're selecting the same columns, but now what we do is we're referencing these columns. We're referencing these columns out here, but it will be the same list of columns, but we're using now the alias RX, which is the intermediate table. Okay, so for this result table, Oracle, once you have all this done, now for this result table, now get these columns. Okay, so the first thing, when you run this, your rental ID column will be null, right? And so if we're going to insert that into the rental table, we have to give that a value, and here's where we do that. So NVL r.rentalID rental s1.nextval as rental ID. So what does that do? If the rental ID is null, then go to the sequence, execute nextval, get that value, and come back and put that value in here. And every one is null, so we'll get a new rental ID number from nextval for every row that we are inserting here. Okay, as rental ID, and now you see here now rx.contactID and rx.checkoutDate, and now this is mapping to these column aliases here. Okay, so RX is the alias for the intermediate table. Contact ID is this alias for contact ID right here. And the same for checkout date, rx.checkoutDate is this alias, okay? And you just get all of these values here into this select statement, and then you just put this select statement inside of an insert statement. Insert into rental, select, and then you have your select from, and then your inner select to do the insert. Okay? Okay, we're getting close here. You don't need parens around this here. This will execute without a paren on this outer select. Okay, let's go back to our lab instructions. I'm out of disk space here, so I'm going to need to stop this. Hopefully this recorded, and then I'll come back, restart my VM, and we will finish up. Okay. We just have probably maybe 15 minutes left to finish this up. Okay.